Hi guys, welcome to this new tutorial. Today we will be creating a Solana program in Anchorgrass to mint an NFT directly on chain using Solana Playground, a QuickNode RPC, and an IPFS service to store the metadata and image associated with our NFT. As a preliminary step, we'll prepare our NFT image and metadata in a decentralized storage service. Today we will be using QuickNode IPFS, a high-end IPFS storage service for solutions that require fast, highly available access with advanced capabilities. In the description, you will find a promo code so you can try this amazing service for free for 1 month. Let's upload our NFT image. In the QuickNode.com dashboard, go to Storage and then Files. In the gray area, you can drag and drop your image. Let's copy the content ID that appears next to the name of the uploaded file. We will append this to the QuickNode.com myfilebase.com/IPFS, exactly as shown on screen. To get the URL we will use, it's important to test this URL in the browser to make sure everything is correct. Now we will proceed to create the metadata for our NFT. We will base this on the standard created by Metaplex for Solana metadata. You can check the Metaplex documentation for more information. I'm leaving a link in the description with more details. Our metadata will be a JSON file with the parameters, name, symbol, and description that we will choose for our NFT. We will create the image parameter where we will place the URL we just created, an empty list for attributes, and the properties parameter with a file's property. This will be a list with an object that will contain the type of file we uploaded. And you read this identifier in this format, IPFS / plus the identifier. With our JSON file ready, let's go back to the file stop in QuickNode.com and drag and drop it like we did with the image file. Now we have our files ready to continue. Let's go to beta.solpg.io and connect by creating a new wallet. Click on Not Connected and then on Save Key Pair and continue. Here we can see the address of the created wallet. Let's create a new project. Give it a name and choose Anchorgrass and create. Warning. For the contract we are going to deploy, we will need approximately 10 SOL on devnet to fund our wallet. We need to pass the address on the Solfaucet, which allows us to fund 3 SOL every 24 hours. So we will need several days to complete this funding. Alternatively, we suggest using other wallet addresses and VPNs to speed up the process. Let's configure SolPG to work on the Solana devnet. Using a QuickNode RPC, click on Settings and then the Endpoint tab. Select Custom and paste our private QuickNode RPC for the Solana devnet. Go to QuickNode.com. To create yours, we will remove the code we don't need and keep the main anchor line import, the default program ID declaration, the program and accounts derived declarations. We will import all these libraries and necessary elements like this. These libraries contain all the standard functions needed to mine new NFTs on Solana, and we will need each one in the process. Below this derived accounts attribute, we will define a structure with all the accounts needed to interact with the program. Called create NFT that will have an info parameter, meaning it will only remain in memory during execution of the instruction using this structure as context. The first account we will define in our structure will be the authority. We will define as a public signer account with an info lifetime. All accounts we define in this structure will be public and with this lifetime. We will define attribute for this account, adding the following line and inside parentheses the word mut, meaning mutable, meaning the authority can change in the future. In the same way, we will define the payer account with its mutable attribute. Now we declare the mint account of type account, and that will hold a mint structure. Our mint account will have the following parameters in it. Because we must initialize it, we set the payer account as the account that we pay for initialization. Now we define the parameters of the internal mint structure, decimals at 0. For being an NFT, we pass the authority account as the authority for the mint structure. The same for the freeze authority parameter. And now we establish the C to create the derived address, which will have first the word mint in bytes and the ID parameter in bytes. This ID parameter will be obtained from the instruction we will create in the contract, and that will receive it when invoked to mint an NFT. Therefore, we must declare this attribute, which will be taken from this instruction as follows. Now we will create the token account that will hold a token account structure that allows us to associate the mint account with the account that will receive the minted NFT. Its parameters will be in it if needed, meaning a new account will be created if it doesn't exist. We will send payer to our payer account. For the mint parameter present in the associated token structure, we will send the mint account and also the payer account as authority. Now we declare the following necessary accounts: the associated token program account, which is the anchor SPL program that associates accounts, the rent account of type sys var that helps determine rental costs, the system program, which is Solana's main program, the token program, the program that allows creating tokens on Solana, the metadata program used to associate metadata with accounts based on the Metaplex standard. Finally, we declare the unchecked accounts, master edition account, and NFT metadata accounts. The master edition account is necessary to ensure a token on the Solana network is effectively non-fungible by associating it with a master edition account. Through this, more instances of the token's information can be created, all associated with this single account, to create different types of NFTs. We will define the following parameters for this account. Mutable seed will be defined exactly as follows. The bump parameter, we must place this line because this PDA will be generated by the metadata program. We must also add this line with the check word to notify the compiler that we are working with an unchecked account type account. For the NFT metadata account, we will establish the following parameters, very similarly to how we did it for the master edition account. With our creative structure ready, we will start creating our program. Below the program attribute, we create the public NFT program module, and we import the entire parent module with this instruction. We will create the public function, create single NFT like this. We will specify the arguments it will receive. First, the context, where we will bring all the accounts we created in the created structure. Then the NFT ID, name, symbol, URI, price, and amount. Our function will call the following three functions in this specific order. First, the mint2 function, we import it from the anchor SPL token library. And then the create metadata account v3. Create master edition v3 functions from the anchor SPL metadata library. If we go to the Rust documentation for the mint2 function, we see it receives a CPI context within which there will be a mint2 structure defined in the same library and an amount. The CPI context is used so our program can interact with other programs on the network. We need to define this context through the new with signer function. Since it will require a seed to sign transactions, the new with signer function receives the program we will interact with. This program we have defined in our create NFT structure, and therefore we access it through ctx.accounts.token program and read its address with the to account info function. This is Solana's token creation program. The next parameter of the new with signer function to create the CPI context will be the mint2 accounts array. This will contain the authority defined in the same way in our context, the account that will receive the NFT, which would be the account associated with the token's mint account, and the wallet that paid the transaction. And finally, the mint account, or we could say the token's identity on the network. All these accounts come from the context we have already created. Finally, the function will receive the list of bytes that will make up our seed as follows. We must declare this seed before as follows. First, we convert the ID seed as a parameter to bytes. Then we declare our seed as an array that will contain first the string mint converted to bytes, our ID bytes variable converted to reference, and the month accounts bump from our context obtained dynamically and referenced like this. This will be the seed that will sign in the calls to all following functions. We will add the message executing mint2 function. Now let's build the call to the create metadata accounts function. In this case, the parameters will be first a CPI context created again with the new with signer function, a data v2 structure, and two booleans that we will send as true. The first to set the authority account as the signer, and the second to make the metadata mutable. Finally, the word none for the collection details. The CPI context we will build first with the metadata program account coming from our context. This will be the program we will interact with in this function. Then we will send the create metadata account v3 structure with the following parameters, all obtained from our create NFT structure. Payer, mint account, the NFT metadata account, the minting and update authorities, which will go with the authority account, the system program also available in the context, and rent. Finally, the function will receive the seed we have already created it and have available. We are missing filling in the parameters for the data2 structure, which would be the name, symbol, and URI that come as arguments to our create single NFT function, and the seller fee basis points parameter with a value of 0, and the creators, collection, and use parameters all in none. We will place the message that the create metadata accounts function is being executed. We will make the call to the create master edition v3 function in the same way with a CPI context, created with the new with signer function and the Metaplex app 1. Like this, the new with signer function receives the metadata program. It create master edition structure with all these accounts from the context. Master edition account, the payer account as payer, the mint account, the account with the token metadata, the minting and update authorities, the system program, the token program, and rent. Finally, we place our seed to sign, and we will place the messages executing create master edition function. At the end, a message that the NFT has been successfully created, and we complete the function with this OK. Let's execute build in the terminal, and we get the result build successful. Now we deploy our program with deploy. And after completing this process, if we go to the transaction history of the wallet associated with SolPG, we can copy the transaction hash in the Solana FM. Using the QuickNode devnet, we will paste this hash to verify the details of the creation of our program. We are now ready to test our program. We will do it using SolPG. We go to the test tab represented by this small test tube, and here we see our create singlet function with all the parameters it receives. We place an ID, name, symbol. For the URI, we need the seed of our JSON file we uploaded to the QuickNode IPFS. We will append this CID address just as we did with the image URI. We can enter the resulting address to check that it points to our JSON file as we created it. And we will place this whole address in this URI parameter. As price and amount, we will put 1. Now for the authority, we will place our address. The same for the payer. The mint account we must derive from a seed according to the instructions we placed in the create NFT structure. First will be the string mint. So we choose string type and put mint. Then will be the ID to send at the beginning as a parameter. For this, we choose U64 and put 1. We click generate and we have our mint account created. For the token account, remember, this will be the account that associates the mint account with our account. Therefore, we put associated token account, the mint address created. The following accounts have been automatically completed by SolPG. And we need to now place the Solana token metadata program account. I will leave you a link in the description for you to copy this account address and place it in that field. For master edition account, we use the seed generated with the string metadata. Then the metadata program address we just copied from the Solana Explorer, the mint address, the string edition, and we must change the program ID from which the account will be derived to, again, the metadata program address. Since this account will be associated with that external program, for the NFT metadata account, again, we derive it with a seed with the word metadata, the metadata program address again, the mint address, and in the same way we did with the previous account, we will replace the program address from where the account will be derived with the metadata program address. We click test, and in the Solana Explorer devnet, we have the transaction hash that we will place in Solana FM. And we can see how we have deployed our wonderful NFT on-chain from SolPG. We hope this information has been useful and you have already created your first NFT fully on-chain using a Solana program. In the video description, I leave you a code so you can use the QuickNode IPFS completely free for 1 month. Don't miss it. Please like, comment, and subscribe. Until next time.